In the previous video, we made all the basic movements for our pieces, both colors, they're moving correctly across the board. But the code that we have here for these valid moves, they're not the best. And they're not the best because there is too many logic here. There is big function with 120, 130 lines, executing a lot of ifs, a lot of checks. This is not the best. To be hard to maintain in the future. Luckily for us, there is an easy design pattern. If you're used to object-oriented programming, it will be the pattern called strategy. And this pattern, basically what it's going to do is that instead of doing if after if here to check, okay, if it's pawn, valid moves are like this. If it's rook, valid moves are like this. We're just going to say valid moves are the square dot piece get valid moves or something around this. And then depending on the piece type, we're going to execute this differently. But for this to work, we need to have this piece here being a specific model. So each model will implement a different logic. And this is the strategy pattern. We split this logic in different use cases. Wherever it's a pawn, we do it like so. It's a rook, it's like this, and so forth. Let's create then here, inside our models, a new folder called piece. I'm going to bring our piece model inside of it and create a new file which I'll call pawn piece model. Okay. We said that inside the piece model, we need to have this get valid moves. Let's create here then first our function. So export default class pawn piece model and get valid moves need to be a function. Create as a const here, arrow function. And this get valid moves technically needs to execute this logic here. Let's just bring it really quick. I'm going to comment out because it's missing a lot of stuff, of course. So just leave it comment out for now. But we need to execute this logic and then return the valid moves. So let's grab this here. And now return valid moves. This one I'll comment out as for now as well. Let me import this coordinate model. And the get valid moves returns what? An array of coordinate model or no, like so. If now, suppose this is not commented, okay? If now I have a pawn piece model created, whenever I say square dot piece get valid moves, this logic will be executed. So if I create a new piece model for each of our pieces, rook, the queen, the bishop, the knight, the king, I can move this logic to inside each of the models, splitting it. And then we will not have a huge function like we have here with all the logics together. Of course, in order to make that work, we need to make some changes here to our pawn piece model and to our piece model per se. Now, as we have a model for each type of piece, this piece model doesn't make sense to exist by itself. And this is what then we call an abstract class. If you're used already to this, so this is an abstract class. An abstract class means it's a class that is not directly created. You cannot create an object of piece model. It's a class that is meant to be used by other class, by being extending by other classes. So here in our pawn piece model, I'm going to extend piece model, like so. And everything that is here, now it's in the pawn piece model as well. And in this abstract class, we're going to create an abstract method function, which will be the get valid moves. These valid moves will return an array. What is that? It's an array of coordinate model or no, like so. And as this is an abstract, the classes that extend this piece model now can implement it on their own. So just like we have it here, just this has been extending, overriding this implementation, which doesn't exist because an abstract one. All the other ones, they remain the same because they are shared between all the types of pieces. That piece icon, you could also change this, for example, to then return directly. But I like the way it's done here, so I'll keep it at least for now. Now, this pawn piece model can start making this logic work. So let's uncomment this and see what we're missing here. Most of it, we're missing the board, the square, the row and the column, which we can get from the square, so that's fine. Player color, we can just import this. And the check valid move, which is in the move service. It's a function that we create here. So check valid move. It's not being exported as of now, so we're going to export it. Export, and also this one. Maybe export also these interfaces, why not? And now I'm going to import this check valid move. And the board and square needs to be received as a parameter. So let's receive it here, just like you receive. Where is it? At valid moves, we need to receive this. So let's receive it as well. Add all these missing imports. Here square. Okay, let's grab the coordinates, row and column. And we just have an issue now that this square can be null. Actually, here in this case, let's say it will never be null. Always be a square model because we make this check before getting there. So if there's not a piece or there's not a square, we validate it before. So now this square piece get valid moves, we send the board and the square. That just also update in our piece model because we need to receive this here to make sure that it's the same function that we are overriding, board model as well. Okay, everything imported. There you have it. Now square.piece, it's possibly null, so let's make sure that the color is correct. You could make this slightly different, for example, making sure that instead of saying the square, you just send the piece and the row and the coordinates already. Instead of sending the board, maybe you send exactly just what you need. You could specify this further, but as of now, as everything we need a board and a square, I'm going to keep, so just we can change the logic from one place to the other. Now, in this move service, we can remove all of this because this function now is inside the pawn piece model. And this if it's not necessary, as long as the square.piece is a piece, a pawn piece model. So let's remove this. And now we're going to make all of this, all the same changes to the other pieces. So we have the pawn piece model. I'm going to copy paste it. Let's start maybe with the knight, this model, to rename it here, knight, and I'm going to remove all of this logic because this is the specific of the pawn. But I'm going to keep all the imports and I'm going to duplicate all of this and create then a rook piece model, a bishop, a queen, and the king piece model. Okay, let's rename all of this. So knight here, this one is the king, this one is the queen, this one is the bishop, this one is the rook. Nice, nice, nice. Knight correctly. Pawn. Let me close the pawn. We don't need it anymore. Where is the knight? Here. This is the knight. Grab all of this. Place it here. That's it. We don't need the player color. Here we don't need the player color. In all of this, let's remove because the only one that really cares about the player color is the pawn. Please, as of now. Remove this if of the knight because the knight is done. Can close it. Now, rook. Where's our rook? Here is the rook. I'm going to add it here. And this function was not imported before. So let's import it from the move service. I'm not going to delete this because this is also used by the queen. So let's add this to the queen. And now, yes, can remove all of this. Going for the bishop, let's grab this part for the bishop. We add it here. I'm going around moving a lot here, right, the files, but you get what I'm doing. It's just repeating over and over. Now we don't need the column for the bishop. That's interesting. So let's remove it. Let's remove here, clean up, remove these two. And now move for the queen within diagonal. We add it here. Okay, remove this one as well. Close the queen. And now remove this if. Lastly, we have the king. Perfect. That's the king. Remove this. And now instead of creating before, we just say this is our valid moves. And then we're going to return this filter that we did before to remove all the invalid moves after that. How we changed this whole complex function, get valid moves, from 130 lines kind of to 4 lines, 5 lines, if you consider here this, the declaration of it, because we separate this logic for different classes. So here the pawn piece model, do we have more code overall? We do, but it's better structured. And you see that this logic is representing the logic that it needs to be. So a pawn does like this, a knight does like that. Not just you have one move service that knows how to deal with all of it. It's a bit too much. What we need to do now, though, is that when we create, if I'm not mistaken, this is in our board model. When we create our board, we set the new pieces and we just say new piece model. But piece model now is abstract. So we cannot just create an object out of it. We need to create a specific class that we're going to use. So a pawn, a knight, a rook, and so forth. To deal with that, we're going to create a similar logic to what we have here. So the piece icons. But instead of having piece icons, we're going to have here piece classes. And now the pawn is what? Is the pawn piece model. Here we have the knight piece model, bishop piece model. You get the idea. Rook, queen, and the king. Okay, king piece model. Let me export this, piece classes. And now in the board model, we can make use of this because if we have piece classes, let's import it. In the position item dot piece type, we have here a class. So we can say new piece classes from here. And now send it inside this. And this replaces what we had before. Like so. We create a class depending on which class is being used here in this piece classes. Receiving then create a new piece model, but most important, create the specific class that will know how to deal with the movements. Okay? We could remove this piece type from here because technically whenever it's a pawn, right? It's always going to be a pawn. If it's a knight, it's always going to be a knight. And we don't need this property here anymore because I already have specific classes for it. But again, I think I'll keep it for now. And what we could do is that in the pawn piece model, that's if you'd like to, you create a new constructor, which will receive just the color, like so. And here you say super, sending the piece type, so piece type dot pawn and color up to make sure that you don't create a pawn piece model with a type, like with a piece type of a knight, for example. You could make this in order to avoid any pitfall here, but again, up to you, wherever you want to do here. I will keep it like this. Like I think this is nice. And then I can create this here, like so. And I'll of course update all of this. The other ones, the knight, the king, the bishop, the queen, and the rook. Let's add this here. Here's the rook. Update imports, update import. Here's for the queen. Add all missing imports. For the bishop. bishop for the king, add all missing imports, and for the knight. I think this is the last one. Yeah, the knight. No, the knight. Pawn. Okay, all of them have their constructors. And in our piece model, okay, we still have this constructor, but now we can just send the player color, and we're sure that the piece type will always be the correct one for each of these classes. Why to keep the piece type? Because it's easier to check this piece type than to check class of, like check which class are we talking about if we need to make any specific checks. So for now, at least, I'm keeping it as I mentioned before. And even after all this refactor, if we come back to our application, we see that we have an error. Being here, a reference error cannot access piece model before initialization in our bishop piece model. It means that our bishop piece model is trying to access piece model before it was initialized. This is happening because we have some circular errors here, some circular dependencies. Our move service depends on all of these functions, all of these models, so pawn, knight, and everything, these pieces, which also depend on certain stuff of the move service. And by the way, we can remove this. For example, the check valid move and the get valid moves for row and column. This per se, it's not the biggest issue, but you see that there's some circular reference here. So comes to move service and then goes to the piece, comes back to the move service, comes back to the move piece, and then returns here to the move service, which returns to the board. So not necessarily the best, we can work on that. And in the piece model, we have here the piece classes being used even before this piece model is defined. So the problem here is that the piece model class is trying to specify their subtypes. Let's remove this here, all of this, into a separate part where we can use maybe not the piece type can stay, but these piece icons and piece classes, they should not be inside this piece model to avoid the circular dependencies that we have right now. So let's bring this into a constant because these are constants. Let's say here piece info.ts. So I can bring all of these two inside of it. I'm going to export and see that they depend on all of this. Let me add all the missing imports. The piece type being the most important because the piece type is still here inside of our piece model. So I'm going to export it as well. Put it here in our piece info. Now can remove this import and let it be like so. Remove all of these imports we have here. Add all these missing imports. Okay, so the piece type and the piece icons. Here as well, in our board model, we need to update these piece classes, which is now there on piece info. Let me come back to our application, going to refresh, and see that we have another error. So the requested module does not exist. So there's still some errors here, because of course the piece type now is in a different place. So let's import it on all of our piece types, all of our models that we just created. Here, here, for the queen as well, and for the rook as well. Okay, remove this. Let me close all of those. I'm not going to use it for now. I'm going to refresh the page. The error now is slightly different. The request module does not provide an export name piece type. So we are in the initial piece positions. Let's go back. See, I'll fix all these errors one by one. Refactor this. Add these imports. What is the error now? Okay, just the favicon icon. It means that our board is back in place. And now I can play it again as I was doing it before, but after this very big refactor we just did. And refactoring our code, it's super important. Whenever we're developing and going further in our application, should always ask ourselves, can we refactor this a bit to make sure that what we have is good enough for our future requirements? And one other small refactor I want to do is here in the initial piece positions, just to change this interface, or a different name, because I think it would be slightly better. Let me search if there's anything else for piece position. No, this is not being used anywhere, the type, so just here, it's fine. All of that done, I'm closing it. And the next in line is to keep a history of the movements that were done in the game. So whenever we move the pawn, move the knight, move the queen, whatever, you want to make sure of keep track of the movements that were played. Here in our board, let's start here, board, and in our app, no, not the CSS, our TCX. Open here, we have the board, we have the player turn, and every time it's moved, okay, we switch. But I want now here to register this. We can use the state to register all these movements and keep track then, so we can show both to the user who is playing, and most importantly, to know some special movements when they are allowed. And here I'm looking at castling. Whenever you click the king, let me do some more movement here, so we can see this happening. This king could move here as well, performing a castling. So the king would move here and the rook would move here. And this can only be done if nor the king nor the rook moved already. So for that, we need to keep track of all the movements that were already done, and then check these movements in order to guarantee that the rook nor the king moved. Now we can perform this castling technique. Back to the code, let's go then to our move model, which is a file that for now it's empty. I'm going to create here an interface. Actually already exported, so export the full interface, move model. This will have a couple of properties. First of all, it's the from position. So from where the piece is moving, this is going to be a coordinate model. Because the coordinate model, if you check it out, there's a row and a column. So where this piece is going is, and where this piece is going to. So from position to position. You can rename it just like from and to. Can also be, so not create like these big variable names, however you prefer. We also need to keep track of the piece that was used, so the piece type, not piece model, a piece type. We don't need the reference of the whole piece. We just need to know which type of piece that was changed. If it was from rook to 8-8 to 8-6, whatever. Now we go here, the piece, we have also the color, which will be the player color. This is our move model, from to which piece was used and what is the color of this piece. Now in our app TCX, we're going to create a state. So const move history list and set move history list. It will be use state of type array of move model. Now we start, of course, as an empty array because the game starts without any movements done. And whenever a move is done here in the move piece, we need to set this move history list using then the previous value, or you can say current value. With the new one, it will be the current value. This is structuring here this array with a new move. This here, it will be the new move, which we're going to know how to add it. And now this move history list, we could add, let's say, after the board here, just so we can see what is going on inside. And then we're going to create an interface for it, make sure that the user is like in the correct notation, and so forth. Let's add then the move here to our array. This will be a new interface. This interface has the from. Where is our from? Is the current square coordinates. Oops. Rearranged here my lint. Okay. 2, it will be the final square coordinates, where we're going to. The piece. Let me see. How can we find the piece? Here we have the current square. So the current square dot piece dot type. We just need the type. And to finish it up, we have then the color, which will be the current turn. Current turn. Player turn here. There is what we have. So the current player is ongoing. this will be the color of the player that we're going to be. What is missing here? What is the error? There is still missing here. The piece type cannot be null, and as here, piece could potentially be null. Actually not null, it's undefined, of course. So let's come back to our move model and say that technically you don't need a piece. Would that make sense? This would fix it? No, it wouldn't. So I want to keep this as needing a piece type correctly. And we're going to check before adding this if there is really a piece on it. So what I'm going to do here is to involve everything in a if, checking if this piece exists before we really perform this change, which kind of makes sense considering that we cannot move a piece if it's not in that square. I'm going to say here piece, current square piece, or just grab it directly with this structuring. And now if this piece, we're going to send it here and use it here. And now we're sure that as we make this if before, we are sure that this piece type will exist because the piece needs to exist. Let's go back to our game. I'm going to play once and see that a lot of errors will show up. Objects are not valid as React child, blah, 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 because of what we did here. This move history list. Forgot to remove. Let me come back. And now go again. That's nice. To finish this video then, let's create here in our components. I'm going to create a move history.tcx. Export default. Let's maybe copy everything. Oh, the app is still as a function. No. Let's create this as an arrow function here. And do the same here. So const movie history, be a function, export default the movie history. Okay, that's what we have. Return here for now an empty fragment, move history list, or anything like this. Also create an interface props because we need to receive what? This array of move models, which is the move list, right? So the move list. Ref move model, add the imports. This is structured here, move list, props. That's what we have. Now we just need to use this in our here in our HTML. Going to say maybe go for UI ordered UI. Yeah, let's go. Let's start with this, and of course we're going to improve it way better later on. Move list dot map move. I'm going to add this. Add the other parentheses here. Finish this up. And now this will have a key, which can be the move. For now, I'm going to use the index, but we're going to change this later on, of course, because we don't want the key to be the index to be the key, although this would never change. But now I'm going to say here inside this li, I'm going to say move from move to move dot to. Let's say here move dot piece like this, something around this. The correct notation, no, this is not the correct notation, but it's what we like, just what we want to show, just something very, very simple. So here the row and the column, the same for the other one. So row and the column. We're going to get to the correct chess notation in another video. As of now, I'm just simply showing here this very simply, just for us to see this working in place. Am I missing something more? I think I'm missing another one. Yes, another parenthesis. Now in our app, let's create here our move history, sending the move list, which is our move history list. Come back, I'm going to refresh to make sure. Update this, you see, on from 1.4 to 3.4. I'm going to update this correctly, make the correct chess notation, but just that you see that this is working. And now we can see the last movements that were done. And here we finish this video. For the next one, we keep on improving this.